today we are starting chapter 12 on differentiation from for additional mathematics course for O level and IGCSE. Today in this chapter we'll discuss some first order, second order, third order differentials and our higher order differentials. So in this first we will discuss a gradient function. Suppose we have a curve y is equal to x square and the gradient of the chord AB is a line or a chord on this curve which is from point A, it is increasing from point A to point B. So the coordinates of point A is x and y, and the coordinate of B is x plus delta x and y plus delta x. So we have y is equal to x square. So for the gradient we take y2 minus y1 divided by x2 minus x1. In place of this y2 we have x plus delta x square. So because y is equal to x square, so this y is equal to x square is placed here. So this is x plus delta x square and y1 is x. So similarly this x plus delta x is x2, this is x plus delta x, and then a is x. So this becomes, on solving or simplifying, we get this one. This x square cancel out with this x square, and then we have remaining with 2x plus delta x square, and we have here at the denominator delta x. Or further simplification, we have 2x plus delta x. Now we consider that this delta x is very small. If this x is very small, it will converge, this point B will converge to the point A. If this point B is very close to the point A, then this delta x becomes 0, tends to 0. So if this tends to 0, then this differential becomes 2x. This y x square becomes 2x. So as B converges to A or very close to A, then delta x is equal to 0, and this chord AB is called the gradient of the curve at point A. So from this we have obtained that y is equal to x square. For this y is equal to x square, we have seen that dy by dx is equal to 2x, and for this can also be written down by the function of x is equal to x square. The function of differential for this is 2x, and this dy by dx of this x square is equal to x. So dy by dx or f differential x or dy by dx square is the same thing. For every one we can say that dy by dx is 2x, function differential of this function is 2x, and derivatives of with respect to x is also 2x. So these are the same thing. And so suppose we have y is equal to x power n, and then dy by dx can be evaluated as n x n minus 1. So we will use this relationship in all my lectures throughout this lecture. So let's move to the exercise. So 12.1, they will differentiate with respect to x. So we will differentiate all these with respect to x. Similarly, differentiate with respect to x and find the value of dy by dx at different points. So, and some word problems. So we'll discuss all in this course. So first of all, this x square means x power 4 means x power n, y is equal to x power n, then n minus 1. So this is the same formula that we are using here for this. Similarly for this one, and let's move to for this one. So dy by dx x cube x square. So this cube power means 1 over 3, this 2 by 3. So this is n. So dy by dx, this n will come forward, and here n minus 1. So this becomes this. So this is the derivatives of this one. Similarly for this, and for this one, x square x, this is x cube is equal to 3x square. So for this one, here we have x under root divided by x power 3. So we can say this is x 3 power 2 and this is x power 3. We can simplify it to this form. So this dy by dx x power minus 3 by 2. So derivative, if you take the derivative, then it becomes this n comes forward here and then n minus 1. So it becomes this. So this is the derivative dy by dx of this or this. So it comes like this. So the differentiate with respect to x, part 2. So we have to differentiate with respect to dy by dx. Every element will be differentiated. So this is 6 x square. So this 3 will multiply with this 2, becomes 6. Similarly for this 1, 5, and this x 1 minus 1, x power 0 means 1. And this is constant, becomes 0. So this is dy by dx for this one. See, similarly for this one. Here we have dy by dx x plus 5 divided by under root x square. So we can write the delta x x by under root x and 5 by under root x. So it becomes under root x and this 5 divided by under root x. So we can take the differential. This is x power half 5 x above x minus 1 x minus half. So this take the derivative, the same formula, x power n, this is x power n, this is x power n. So using this relationship we have obtained this. Similarly for this one, so we have performed these operations here. X square by x, this is 3 by x. So this is x, this is minus 3 x power minus 1, and this is we take the differential of this one and this one. So we have this. For this one, this is 1. For this one, this is minus 1 minus 1 minus 1 becomes minus 2. So it becomes, for this terms, this is x denominator by this and x divided by this. So this is 5x, x half, this is 5 and this is half x minus 1 plus 1 half this to x plus under root x. This is d by dx. We have to solve or resolve this one. This is x and x power 2 divided by under root 2 x half, and this becomes x. So now solve this one by using x power n, assuming every element. So this becomes this, for this one this, and for the last one is. So on simplifying we get this one. Similarly this one, so we have to resolve it first. This problem can also be solved through the UV method, so but we will discuss it later on. For the time being we are just simplifying it and resolve. Similarly for this one, this could be done like this. Other methods also exist, do it later on. This one is this. So we have to find the dy by dx at a given point on the curve. So let's read the question number 3 again. So we have dy by dx. We have to find the dy by dx at points this, for different points. These are the points that is available on this curve where the gradient has to find, dy by dx has to find. These points lies on this curve and the gradient is also passing through these points. So these are the condition that has to be in everyone's mind, that what we are doing. So this is dy by dx that has to be find for these curves against these points. At this point this differential will be obtained. So we will solve everything, one or two problems for question number 3. Let's see. So let's see the first one, or second one. Let's see. Y is equal to 4 minus 2x square at minus 1 comma 2. So we have to differentiate it. This becomes 0. 4 minus 4x. The differential of this y is equal to this is dy by dx is equal to minus 4x. At this point, for value of x is equal to minus 1, it becomes 4. So the differential is 4. For the last one, y is equal to x minus 3 divided by under root x square, under root x at 9 comma 2. So this can be also be write down like this: x upon under root x, 3 upon under root x. So this becomes under root x, and this becomes 3 under root divided by under root x. So this under root comes up with x minus half. Let's take the differential by this one, this. So this differential comes out to be in this form, and here for this gradient we have to apply these coordinates. So this coordinates, this dy by dx becomes, so it obtained as 2 binary. Let's move to the question number 4. So find the coordinate of the point of the curve y is equal to 2x square minus x minus 1 at which the gradient is 7. The gradient is given, the curve is given, and we have to find the coordinate. Just the reverse of problem number 3. These problems, here the curve and points are given and have to find the gradient. Here the gradient is given, the curve is given, you have to find this coordinate. So for question number 4, y is equal to x square minus x minus 1. The gradient is given, we have to find the gradient is equal to this 4x minus 1. So this becomes 0. So this gradient is also given as 7, so we apply here 7. So get the value of x is equal to this 2. So this 2 will apply here to get the value of y. So y is this, so the coordinates value is 2 comma 5. So this was the required solution. Now let's move to question number, some other questions. Let's move to question number 7. Here the curve is given, the line is given, and this curve and this line meet at two coordinates at P and Q. So we have to find these coordinates P and Q. So this y both equals to y. When this curve intersect this value, then this value will be equals to this for this curve. So now we have obtained this. So from this quadratic equation we will get the value of x. Two values of x has obtained because this curve is intersecting this line at 2 points at this P and Q. So this x is 1. So for this x1 we substitute the values to get the value of y. So we have y is equal to 5. X is equal to 1 and y is same 5. And when this y is same to 5, so this differential is this one, 4x plus 7. So this differential, it becomes 4x plus 7, and then 4x plus 7, so get the gradient for point P, which is 1 comma 5 is 11. For gradient of at point Q, we have this minus 9 by 2 in place of x, so we'll have minus 11. So this is problem number 7. Let's move to problem number uh, problem number 9. The gradient of the curve is given as this. At point this is 7. Find the value of a and b. So this is a curve, and at the point this is this. This is minus 7 is the gradient of the curve. At this coordinate point, we have to find this a and b. So this gradient is given at this point. We have to find a and b. This is the curve. This one value minus 1 and 3, we will substitute 1 and minus 3, and then this equation becomes this. From this we have this, and for differential, we take the differential of this one. So dy by dx, from the dy by dx we have this. So this becomes a b x power minus 1 comes in this shape. So a minus b upon x square. So this at this differential, at this coordinate point, this gradient becomes this. So we have another equation, a minus b is equal to this. So by solving equation number 1 and equation 2, we get the value of a and b. This was the requirement. Now let's move to the point, the curve 11 number. Here the curve y is equal to 1 over 3 x cube minus 2x square minus 8x plus 5, and the line is this. So a curve and a line meet at the point A, B, C. So this curve intersecting this line at 3 different points A, B and C, and we have to find the coordinates of A, B and C. Secondly, find the gradient of the curve at the point A, B and C. So let's move to problem number 11. Here we have a curve, this line is this. So by equating this line with this curve, this becomes this. So by taking out this, by factorizing it further, we have obtained the value of x as this, right? So we will substitute this value in this curvature curve to get the value of y correspondingly for every x. So we have these coordinates a, b, c. By substituting this value of x in the curve, we will get the value of y. So the coordinates are given as 0, 5, minus 3, 2 and 9, 14. This is the part 1, and in the next part we have to find the differentials. So gradient. So gradient for this curve, we have to find the dy by dx, and we have obtained dy by dx as this. So in place of every coordinate A, B and C, we place the values here and get the values for A, for B and for C points, respective x variables. The values of x will be substituted for every A, B and C to get the values like this. So this was the problem number 11. Now let's solve question number 12. Y is equal to 4x cube plus 3x square minus 6x minus 1. Find dy by dx, and then find the range of value of x for which this dy by dx is greater than 0. So here we have a curve, this one, and we have to find the gradient of this curve. So the gradient of the curve is given as this. For the range of value for which the gradient is always greater than or equals to 0. So for this purpose we have this is greater than 0, and eventually it can be written down like this. So on factorization we have x plus 1, 2x minus 1, and from this we have minus 1 and minus 2, and we have to find the value where the curve is greater than 0. So for this range, for minus 1 to plus 2, the value will be this. So this is the solution for x minus 1 and greater than half. The curve will be either 0 or above 0. So this was the requirement, so the solution is this. We have solved these kind of problems in chapter 2 or 2.3, 2.4 exercise. So let's move to so now we will discuss exercise 12.2 in the next session.